Welcome back, everyone. This video is about active patterns. As the name suggests, it has something to do with pattern matching in F sharp. So I'll run you through various examples and pieces of code. Personally, I had a major tough time understanding what active patterns are. Largely because I think the whole concept is ill named. It should have been, if you ask me, it should have been called pattern functions. But who cares about what I think? Uh, so we'll see. So before we begin, let's take a very simple example. I'll copy some code from here. And I'll get rid of this. And then, okay. Now, the very first example that I wish to give you is this much. You have a string and you are doing a basic validation that this shouldn't be an empty string. So you match name with, you get value, which is variable type pattern matching. The value is mapped to the pattern is mapped to the value, and then you're using a when, a condition that the value's length equals to 0, which is if this is empty, this case will be triggered. Otherwise, you are returning true from this particular case. Uh, you may capture this whole exercise into a function, which is exactly happening here. So, and in order to follow the pattern matching practice, you will first of all create a discriminated union, a case of name validation okay and name validation not okay, or I mean not and from here you will say match validate name and name. You are invoking this function which will return this. So you call this function checks the length of the string, returns this in one case and this in the other case, and rest is piece of cake. Rest is not the difficult deal. Quickly repeating myself, this is where the pattern matching and the where and the when and this is all too dirty. So you break it down into a function, and in order to follow the best method of pattern matching using a discriminated union, you create a data type first, then a function return different cases from different branches of your if, and you then do the pattern matching like this. Now, if you look carefully, there are three things happening. One, you are creating a dedicated type. Secondly, you are writing a function. And thirdly, you are not pattern matching on name like here. You are pattern matching on the result of this function call. Okay. And there are two aspects to active patterns. One is the second aspect I'll talk about later. So the first aspect is simplification of this whole process. And the second aspect is pattern matching. Like I said earlier, the name should have been pattern functions. Active patterns are nothing but functions. Okay, so this is where the name is sadly extremely misleading. You should always look at active patterns as functions because that's what they are. They are highly syntactically confusing, irritating ones, but they are functions at the end of the day. Okay, so you can simplify this and this by using active patterns, which is you are creating functions. And because those are functions, the beauty of functions then come into play, which we will see later. So the first thing I'll do is I'll copy this much. Now I'll get rid of, instead of getting rid, I'll just say this, and I'll copy this much. So first thing first, this function is a merger of these two. That's it. You are not creating a discriminated union separately. You are creating it here. and you pack it with these brackets, and this much, this is actually a function, as we will see in the later examples. The whole purpose of this function is to act upon this input and return this or this, either this case or this case. So earlier we were doing validate, return this case which was declared above, or this case which was declared above. Instead of doing this, we are declaring the cases here, and from here we are saying invalid name, and from here we are saying valid name. Thirdly, and which is easy to ignore, is we are back to matching name. We are not matching validate name. We were matching name, we are again matching name. And instead of all of this logical thing packed here, is now part of a function. And you simply say match name, invalid name, which comes from here, or valid name, which comes from here. So when you say match name and you follow with these cases which are coming out from such a function, the active pattern function for the lack of a better word, the function knows this, the compiler knows what to do. The compiler is indirectly for you calling this function whatever with name. So for you the life is simpler, you just match the name. Okay, quickly again, you don't have to separately create these two, and you don't have to do a function name whatever, you don't have to match on the return values of functions. You combine these two steps into one step. The function name is replaced by this bracket, cases like this, and from this function you will return one of the cases. And when you are matching, you are doing match value and the cases which are the return value of this function. All right, one more example. This is representation of months. And yeah, so I'll get rid of this much and this much. So first thing we have done, what we have created is a type which represents different months, and then what we need is a given number to month translation. So here these types, I have done this to map indexes with these values, okay, these cases, so that Jan comes on 0 index, Feb comes on 1st index, March comes on 3rd index, and so on and so forth. Again, this is a function which takes one parameter, num. If the number is greater than 1 and the number is less than m dot length, because the indexes are 0 based, then what I am doing is I am returning one of these values, okay, in the valid month case. And if the value is outside this range, I am just returning invalid month. You can read this as some value, none value case. What you have ended up with is a discriminated union. Loosely speaking, in case 1 you have data, and in case 2 there is no data. So valid month has data of type month. So if you look at valid month, it is, ignore the choice and the fancy things appearing right now, not important for this discussion. So for valid month, there is a month involved here. Invalid month, is the unit part, okay? So how do we match? Again, match 1 with, we are not calling any function, that the compiler will do for us. Match 1 with either this case or that case. In case of invalid month, there is no additional data, so nothing appears here. And in case of valid month, M comes. Similarly, match 13, and the rest is all printing boilerplate stuff, so you can ignore it. So I hope you can see the benefit of using this approach. You can uh, short circuit lot of ideas and write more to the point code. Okay, now so far it's all about utility and convenience. The another example that I wish to showcase is of how pattern matching, active patterns, which I would like to call pattern functions, are more powerful than just vanilla patterns. So first, let me give you this example, because this is where you have to also understand one more idea. This is also known as partial active patterns. Okay. Sorry, I think I've copied the incorrect thing. No, I was supposed to copy. Yeah, I was supposed to copy this much. Yeah, okay. So pay attention what I'm doing. The first thing I'm doing is this, pay attention to this, this, and then this. This says, give me any number. I'll compare it with 100. That's the overall purpose of this function. Is this number greater than 100 or not? If is this number less than 100 or not? Now, when you create active patterns and you end it, the last case becomes an underscore or comes as underscore. This is known as a partial active pattern. This is where things get syntactically too much sugary, too much short circuit is happening here. But what is, simply speaking, what is happening here is the whole ideology of option, sum, none, and active patterns, they get combined here. The moment you encounter something like this, the compiler assumes you will return some value of this type, of this case I mean, or none. You cannot do anything fancy, anything extra. You have confined your use case to, I want to use active pattern along with, since I'm dealing with optional data. Okay, so when this happens, I have this, otherwise it's a none. Okay, similarly, so what you're saying is if num is greater than 100, then you're saying some num which maps to this case, none which maps to this case. Less than 100, num is less than 100, maps to some num maps to this case, none maps to this case. Now you're creating a wrapper function. You can directly use these two, not a problem, like the previous examples, but I wanted to make it more comprehensive. Now you have created a function, compare num with 100. Give me any number, I'll compare it with 100, and again match num with greater than 100, in this case less than 100, in this case seems the number is 100. So this is where this function compare num with 100 is combining these two, and you can say compare 100 with 1, you should see this as the result, and so on and so forth. Nothing complicated in this part. The thing you must understand is how these partial active patterns play a role. Okay, now, and also if you see greater than 100 is int option, less than 100 is also int option. So if you had some x would have the value. Similarly, greater than 100, x has the value. So on top of this, I wish to build the last example, which more or less completes the scope of active patterns, is partial application. So if you look carefully with these functions, we have knowingly or unknowingly tied up everything with number 100. This active pattern is working for 100. this active pattern is working for 100, this entire function, the messaging and whatnot, the cases, everything is tied up with 100. Okay, so whatever happened to reusability, and that's the advantage of active patterns, that the typical pattern matching in F sharp is hardwired into your code. But with active patterns, you can create more dynamic things. So I'll show you an example. Let me first of all copy these two. And here comes a second parameter. If you compare this with this, the key difference is this was operating on 100. This function on the other side is operating on compare with. If num is greater than 100, if num is greater than compare with, rest is same. Similarly, this was tied to 100. This is based on compare with. Here you are comparing greater than, here you are comparing less than. So you have two general purpose active patterns that are dependent on the first parameter. Then what we will do is do a friendly partial application. Okay, partial application of this thing is here. So you're saying, remember I said this is a function. So you're saying call this function with 5000 and you end up with another active pattern which has 5000 baked into this. Similarly, less than this, and 5000 is now baked into this. And then not a big deal. You have to just create another function which utilizes these active patterns. Okay, so here everything is hardwired. Here you have created generalized functions out of which you extract the specialized functions. Okay, so just like functions, active patterns give you the flexibility slash composability, and it's not very easy to realize or understand the perfect way to use active patterns, or whatever problems can be solved with active patterns, or these are partial active patterns and this is partial application. So there is just too much. Active patterns are slightly messy and a complicated subject. But once you practice and you refactor your code over period, you learn better ways of doing things. So on that note, I'll conclude this one. See you in the next one.